Hello and welcome to this particular video. My name is Will, and in this tutorial I would like to go over the topic of interfaces. What is an interface? What are the advantages and the features of interfaces, and how can we as C# developers benefit from what interfaces have to offer? It's going to be quite an interesting tutorial. I think it will shed some light on a topic that may have been kind of mysterious for, especially, just say, like more on the junior to the lower intermediate side of developer prowess. But rest assured that by the end of this tutorial, I'm pretty sure that you will have a solid and fundamental grasp of what interfaces are and some of the creative ways you can use them. So without much further ado, let's get straight into this demonstration. Firstly, what I would like to do for the first half of this video is to clear the air on the definition of what an interface is. Before we go to some of these notes that I've taken, I would like to go to the learn.microsoft website to go straight to the source, and I'm going to just read out some of this paragraph. So, an interface defines a contract. Any class, record, or struct that implements that contract must provide an implementation of the members defined in the interface. Now, this is all well and good, but for me personally, this is probably the best kind of definition you're going to get, but it was still kind of weird for me to understand. It was a very theoretical sort of explanation, so I want to get a little bit more practical to help kind of illustrate what this means. What is this actually saying? Contracts, you know, do we have signatures? What's going on with this? So, what is an interface? So, very similar to the learn.microsoft.com definition in a sense, an interface is a class that defines discrete function calls. Imagine a dedicated class that has function calls. Just like when you call any function in your main.cs or your, any kind of class you have, this is what interface basically denotes. Now, interfaces do not contain implementation logic, but only function name and signatures. Okay, this is kind of important to know, and when we get to the Visual Studio IDE side of things in this tutorial, things will make more sense as to what a signature is. I'm sure you'll pick it up quite fast. So C# does not implement multiple inheritance, so this is kind of one of the features of interfaces, in the sense that interfaces can be used to define multiple behaviors for a class. So what are the key features of interfaces? How can we benefit from interfaces? So, protection, right? Functionality can be accessed through a public interface, which a public interface can access internal classes. So you can have a protection level for a class that's internal, but you can expose the implementation logic and functionality through public interfaces. So you have a layer of security there. This is a very good thing. The public interface does not describe implementation logic, only the internal referenced class. Again, we're hiding the implementation behind the, should I say, the contract, the interface. So I have here a very simple example, and I really do hope this helps to shed some light into what an interface does and its function in C#. So say we have two classes, mother underscore behaviors, daddy underscore behaviors.cs, okay? And we have some function logic. So the role of these, let's just say we have these two classes, and let's say we have another class called child. And the idea is we want to pass certain behaviors of mommy, certain behaviors of daddy, onto the child. How do we do this using interfaces? So in the mother class, we'll have implementation logic describing her hair. Maybe she has blonde hair, maybe she has brunette hair. Her eyes, and maybe her implementation will describe blue eyes. Maybe mother's implementation will describe blue eyes, green eyes, black eyes, who knows. Food taste, sweet, salty, these could be anything. And on the daddy side of things, hair, maybe his implementation, maybe daddy's implementation will be black hair, maybe daddy's implementation will be blonde hair. It may even be different to the mother's implementation. This is what is key here. The function names, the conventions are the same, but the implementations may vary. This is going to be somewhat important later down the line, and you're going to see how that comes into play. But that, notwithstanding the fact that you may have implementation logic that is different. So here, it is emphatic that the mother class likes cats. As you can see, there's actually a function called a function named likes cats, and there's the implementation logic that carries out this functionality. And similarly, daddy likes dogs, so there's implementation logic pertaining towards liking dogs in daddy's class. And as you can see here, we have iBehaviors interface. So this is an interface. This is the contract. This is the documentation that holds the contract. And the contract doesn't have the implementation logic. The implementation logic is described by these behavior classes, as it were. But as you can see, we have function calls in our interface, on our contract. Okay? We have likes cats, likes dogs, food tastes, eyes, and hair. Now, to reference our contract class to our behavior classes, we use the colon. We denote this colon, and then we define, and then we name our behaviors interface up here. Or I say name, but we reference it rather. So our interface is referenced up here, following the colon on when we define our mother behavior.cs, and the same with daddy behaviors.cs colon. And then we write behaviors interface. So now there is a reference between these classes, as you can see. And then the child simply has to implement, or rather reference these classes that reference the implementations. So what happens here? Now this is where things get quite interesting. So the child class will have access to the iBehaviors interface. And just as you construct any normal class, we will say iBehaviors interface, and then we give it a name, iBehaviors, equals new mother behaviors. So we are constructing this class with reference to the mother behaviors class, but we started off with the interface. See, this is where the fun stuff happens, because now we're basically telling C#, okay, use the interface to access the functionality pertaining towards mother's behaviors. So now mother's version of behavior implementations are now accessible. And in the very same way, iBehaviors is equal to new daddy behaviors. So now we have daddy's version of behaviors implementations are now accessible. So in theory, this all hopefully makes sense. And so what I'm going to do now is demonstrate all of this using Visual Studio and C#. So I'm going to close this, and we're going to get straight to work. So I have here a project, interface demo 2, that's the name of the project. And we have a user interface. So imagine a UI with a button click. I don't want to go straight to the XAML because it's going to waste time as things are going to load. But it's just literally a screen with like a button. That's all you have to really know right now. And when you click the button, we want to call our interface. So what I've gone ahead and done is I've created a class called iUpdate. As you can see, it's a public. I made it a public interface. It was internal before by default, but I made it public. Interface iUpdate, okay? And right now it's empty. And then you're gonna want to go ahead and create another class. I've gone ahead and called this update, but for the sake of demonstration, I'm gonna keep it similar to what we had with the mother, with the mommy daddy kind of example, because I kind of like that. So I'm gonna delete this. Update.cs will be deleted permanently. Let me make sure I know what I'm doing. And hopefully Visual Studio doesn't just stall on me for too long. Yeah, why not I keep things as similar to the examples, just so for the sake of illustration. Excellent stuff. So why don't we start with the behaviors first? Because that's where the implementations are going to be. So I'm going to right click, I'm going to add a new class. And I'm going to say mother underscore behaviors dot cs. Okay. I'll just wait for Visual Studio to load my class. And as you can see, we have our class right here. It's internal protection level, mother behaviors. Okay. Now I'm going to right click my project again. I'm going to add a new class. And this time I'm going to call this daddy underscore behaviors dot cs. And I'm going to wait for Visual Studio to load my new class. As you can see, I've got another internal class, daddy behaviors. Just going to zoom in slightly so things are easy to read. So if I start with mother, with our mother class, I'm going to go ahead and define some behaviors. So let's say, for example, public return, oh sorry, not return, public string, we're going to return some strings that kind of simulate behaviors. And let's start with eyes. And I'm just going to say return, I'm going to return string values. I'm just going to say green eyes, just like that. Oops. Let's keep things very simple. Public string hair. Oops. Make that capital. Let's say return blue, oh gosh, sorry, blonde hair. And you know what, eyes and hair is enough for now. Let's not go too wild here. So we have eyes and we have hair. Okay, let's go straight to daddy's class. I'm going to copy and paste this just so I can save some time, but I'm going to change the string values. So I'm going to give daddy, let's say brown eyes, and let's say brown hair. Let's make it the same. So daddy behaviors are brown eyes and brown hair. And then we go back to mother's behavior. We have green eyes and blonde hair. Okay, cool. Now, instead of having a child class, actually, you know what? Let's make it, I was going to use the main page.cs, but again, for the sake of demonstration, let's make this very similar to the demo, or rather the example I gave. So we will make a child class. I'll say child.cs. I'll wait for Visual Studio to load this my new class. Okay, this is also an internal class, which we may have to change this protection level for now because I might be accessing something via the main page, but we'll see what happens. But in any case, we're not going to interrupt the flow of how we work the interfaces. So what I'm going to do, I'm going to right click. I'm going to add another class, and I'm going to add my interface now. So instead of hitting class, I'm going to hit interface over here. This is quite important. Make sure you hit interface. This might not work if you don't. And I'm going to say something like I behaviors. Hold on. Make sure I spell that right. I'm in the UK, so I have to use OURS. I behaviors.cs. I'm going to wait for my interface class to load. Awesome. Excellent stuff. So I'm going to change this to public. And I'm going to copy iBehaviors. Now I want to make a reference for this document to hold a contract of the signatures for mothers and daddies implementation logic. So what I'm going to do, I'm going to reference this contract document. I'm trying to find mothers, I couldn't find it over here. So I'm going to say mothers colon. I'm going to say iBehaviors, as you can see there. Everything is parsed. So now there's a reference between these two documents. And similarly, I'm going to go to daddy. I'm going to do the same thing. Daddy colon iBehaviors. So now there's a reference between class, our class, and our interface. Okay. So we have eyes, hair, simple stuff. iBehaviors. I'm going to define our function calls. So we'll start with eyes. Oops. But I can't forget the type. So the return type is string, eyes. As you can see, two references have automatically come up, both from the mom and the dad side. of our classes, figuratively speaking. Two references already have popped up, so we know we're on the right track. I'm going to say string hair. And this is where the naming convention of keeping the naming convention the same comes into play. We can benefit from this sort of referencing, similar references, different implementations. And this all comes into how you structure your code, the architecture of your code. So this is just, again, just bringing to light a way you can structure your code, implementing and utilizing interfaces. So hopefully that makes a little bit of sense. So we have our contract defined, okay? Everything is working quite well, quite fine, rather. So, okay, I'm gonna go here to our child class. I'm gonna make it public because I want this to be accessible, at least for the main page file. So I'm gonna go ahead and make this public. And now what we're gonna say is, okay, let's return a string. So let's say something like public string child behaviors. Okay, I haven't defined a return type, hence the error. So I'm going to say we have one interface, iBehaviors. I'm going to say iBehaviors equals new, and now I'm going to construct this with the mother class. So I'm going to say mother behaviors, and I'll put the brackets. As you can see, that goes through. Now I'm going to say iBehaviors. I'm going to access it with a dot operation. And as you can see, we have access to eyes and access to hair. And this pertains towards mother's side of eyes and hair. So let's start with eyes, like this. And let's have a string value up here. Let's say string, and we'll call it behaviors equals string.empty to start off with. So I'm going to go ahead and say for our string behaviors is assigned the eyes. So remember, this function returns a string. So I'm going to say it like that. Then what I'm going to do, I'm going to say iBehaviors. I'm going to also, actually I don't need to do that. I already have an instance of iBehaviors, rather an instance of our class. We can't actually instantiate this iBehaviors. It sort of has a static context. So what I'm going to do, if you try to, and I'll see, I might as well show you. iBehaviors, let's just say I equals new iBehaviors. This doesn't work. As you can see, we have an error. I'm going to try and get the IntelliSense up. iBehaviors is a type which is not, oh sorry, that's not the right one. Cannot create instance of the abstract type or interface iBehaviors. So that's why this situation demands a class rather than an interface for the construction. So we're going to go ahead and say new, which I've already written, daddy behaviors. And that goes through because of that reference that we made earlier. And then this time I'm going to say behaviors is equal to behaviors plus. So I'm concatenating strings right now. Let's give it a bit of space. 1, 2, 3, 4. And I'm going to say plus. I'm going to concatenate some more strings. And I'm going to say, I'm going to change that. So I'm going to call it iBehaviors as well. So I can say iBehaviors. Hopefully I spelled that right. Access. And now I have access to eyes and hair, but this is on daddy's side. So what a mix. Okay, this is interesting stuff. So let's give, so for the child class, I'm going to pass mummy's eyes and daddy's hair, something like that. Okay, for this example. And I don't need this because I've already defined iBehavior, so I can get rid of that. Okay. And I'm going to return the string at this line here, line 18. Like this, okay? And thus we have no errors. Okay, I hope you guys are following me so far. because what we're going to do now is pass this, we're going to call this function in our main class. So I'm going to go to, where's main.cs? Should be here. Main.cs implementation. So we have a button in our user interface. So I'm going to say tb, because I also have a text block called hello world text block dot text, and you're going to see what this all does. Text equals well, before I do, I'm getting ahead of myself. I need to construct the child class. So I'm going to say child. So I'm making an instance of a child equals new child. Let's see if that goes through. And then I'm going to say, okay, so for my user interface, I'm going to call our function in child behaviors. I'm going to basically return string values like this. Okay. Have a couple errors somewhere. Let's see. 933. Not sure what's going on there. Okay, cool. And let's see what happens. So let's run this program. I'm gonna hit local machine, I'm gonna hit play, and we're gonna see what happens. If everything has gone according to plan, then we should see a mix of mommy's behaviors and daddy's behaviors simulated as text. Okay, so hopefully things will kind of come up in the UI without much issue. I know this user interface might seem a little strange. I was going for something, but I did change the idea midway. As you saw, I kind of lent this tutorial to the example I gave on the OneNote documentation. But anyway, when I click this button here, we should see this implementation fire. So let's see what happens. And voila, as you can see, green eyes, brown hair. We have mom's green eyes and we have daddy's brown hair. This simulates inheritance. This simulates the multiple so what this means is that we have multiple behaviors defined in two discrete classes. Thus, we have sort of simulated multiple inheritance in an environment, i.e. CSharp, that doesn't actually support multiple inheritance. This is where interfaces come into play. And we have the heightened security because, again, we have just exposed public functions written in an internal class, so the class is internal, shouldn't really be visible, but then using a public interface, iBehaviors, we were able to expose our public interfaces without exposing the implementation logic on the public layer. So this is the security advantages. And with that, everybody, I would like to thank you for sticking around for this tutorial. I hope you found this demonstration entertaining, educational, and please leave comments, feedback, or criticisms in the comments. All the feedback I get really does help me to improve the channel and the content I provide. And please do check out the link in the description if you want to check out my web store, CSharp Snippet Store. You'll find some value there too, I'm pretty sure. So thanks again, guys, and I bid you all a great day. Bye-bye.